Hello everyone, and welcome back to another IoT Sparks live webinar. And today we have another interesting topic that we will discuss together with our guests. And as you can see from the title, and probably you know from our communication before the webinar, it's all about mioty today. We're going to explore this innovative technology. We are going to talk about what makes these technologies so special and why it is a great choice, a great option for massive IoT in large deployment and wide area network. And so I don't want to waste the time, even if I can see people still join in, so I would probably talk a little bit more so that everyone can join. We are very punctual today, so I would spend 1 more minute talking about this webinar and about mioty and miotyGo. miotyGo is a new tool, and you will discover today what it allows you to do. It's basically software to simplify the access to this new technology. And as usual, I'm not alone in these webinars, and you can already see my guest here today. And so I will start. Let me introduce them. I will start from Professor Jörg Robert. He's a full professor at the TU of Ilmenau, Technische Universitat. Let me try to pronounce it.
Right.
And
Yeah, that's perfect.
he's a professor and researcher, especially in the field of antennas, wireless communications, LP1 technologies, and also he's part of the EEE standardization group regarding this topic, especially in the smart metering. Correct me if I'm mistaken.
Yeah, that's correct. So thank you very much for that.
And LP1, and of course IoT. So it's the best person to talk about this topic today. And together with Jörg, my colleague, Daniel Szabó, from LORIOT, is our lead of the embedded development team, and he and his team are responsible for developing our embedded solution, like our, for example, our gateway software and miotyGo as well, that was realized together with the Mioty Alliance, that is hosting this webinar and is also a gold sponsor of IoT Spark event in September. So let's get started, and let me hand over to Jörg. I invite Daniel, and I'll do the same, to switch off camera and mute our microphone so that the audience is all for Jörg. Enjoy the webinar.
Okay, so thanks again, Dario, for that nice introduction. Yeah, so I would like to introduce to you the concept of mioty. So what's so special about mioty? Because maybe you already know other low power wide area network systems like LoRa. And so the question is, so why do you need a different solution than LoRa? Okay, so let me just switch to the next slide. So the general point, I mean, so that's most likely already well known to you. So what are low power wide area networks? So low power wide area networks mean that you have low power on the transmitter side. At the same time, you want to have a long range. Furthermore, because you have low power and long range, you typically have a low bandwidth or low data rate between the transmitter and the receiver. So in general, you have very short packets, so just a few bytes of data to transmit. So there's no chance to transmit any kind of video and stuff like that. So it's really focused on some measurement data. And the focus is mainly on the uplink. And so you see that here as an example. So you could have some kind of gateway located on top of a high tower, could have a height like 100 meters. And then you have your tiny low power wide area network transmitter. And this transmitter then tries to communicate with the base station, with the gateway here. And even though the transmit power is maybe like 10 milliwatts, you can easily reach distances like 40 kilometers if the gateway is really elevated on top of such a high tower. So, I mean, that's already well known to you, but what does that mean? I mean, that means we really receive the data of a very, very large area. And this means that we get interference. Why do we get interference? Because we are not alone. So there are other people, other systems like wireless garage door openers and stuff like that also operating in that frequency band. And so there are maybe also other users of low power wide area network systems that also operate in this frequency band. And of course, that leads to huge interference. And especially when you now take a look at the typical radios, if you have such a highly elevated system, so it's pretty clear that you really sum all the interference that you have in that specific area. And that's, of course, a very, very big challenge in case of these low power wide area networks. But before we do that, let's just compare mioty against the well-known LoRa standard or specification related to the sensitivity that you're able to achieve. So what you see here, so that's basically the required reception level. And this is then the resulting packet error rate. So 10 to the power of 0 means 1. So that means you lose 100% of the data. 10 to the minus 1 means that's a packet error rate of 10%. 10 to the minus 2 means that you have a packet error rate of 1%. And now you can see measurement results of different systems. And for instance, here you see the LoRa with spreading factor 7. So that achieves a sensitivity at 1% packet error rate of like minus 129 dBm. But on the other hand, it offers a very high data rate compared to the other modes. And then if you switch from SF7 to SF8, so basically half the data rate, the bandwidth of your system, and this results in a loss of 3 dB. And 3 dB means in linear scale, you require twice the power or half the power in this case. And you can now see when we then switch to the different modes, then eventually you always reduce the required reception level by 3 dBs. So that means that you always require half of the transmit signal level. And eventually you will then end up with minus 140. And there you see all the different systems co-located. So LoRa, SF11, SF12. So they basically require minus 140 dBm of sensitivity. And also mioty also requires signal levels in the order of minus 140 dBm for error-free reception. This means that mioty has more or less the same sensitivity than LoRa SF11 or SF12 in the channel where you don't have any kind of other users. And so we call that AWGN channel, so additive wide Gaussian noise channel. So that's basically the best case channel that you can have. And the only limitation of the transmit distance is really noise that is present there. So that's the idea of it. But of course, if we take a look at the reality, so that's a little bit different. Just take a look at that figure and just think about it for some seconds. So what do we see here? So that's the spectrum that I measured in the US, more precisely in the downtown area of Atlanta, USA. And what you can see here, so that's the time axis. You can see that this covers approximately like half a second, stuff like that, or a little bit less. And this is then a bandwidth of 5 megahertz. And what we can now see is how different services then access the channel. For instance, you can see on that frequency a signal that is there for a very long time, or you can see a lot of other accesses to the channel, and they all use that channel because here in the US, the 915 megahertz is a license exempt frequency band. And what you can also see, if you take a closer look, there's a LoRa signal. And now let me just zoom in. And you can now see the LoRa signal, and you can see these classical up chirps, the 2 1/4 down chirps, but you also see that this packet basically collided with some other signals that have been transmitted by another user. And therefore, this interference eventually gets very critical for many systems like LoRa, because you have a very, very big footprint. That means you have a very, very high bandwidth. And on the other hand, you have a very, very long transmit duration. So if we take a look at Europe, for instance, a LoRa SF12 packet can easily last like 1.4 seconds. And this means the probability that you get really hit by some other service eventually is like 100%. And this means that you're not really limited by the sensitivity, but you're limited by other users that also use these frequency bands. And that's especially the problem in case of these low power wide area networks, because you really cover a very, very huge distance. This means you collect a lot of interference from other users and they will hit you. And especially if you have a system that has a long transmit duration, and because you want to achieve long range connectivity, you have to transmit over a long time, then you will eventually get hit by 100% or with 100% probability. Okay. So how does mioty solve that issue? And mioty basically solves that issue by splitting the data in many, many tiny chunks. And what we see here are different representations of low power wide area network signals. So this is, for instance, a LoRa SF7 signal. That's SF8, 9, 10, 11, 12. And you see always how the transmit duration really increases. And eventually the on-air time for the LoRa packet is like 1.4 seconds. And you see the bandwidth of 125 kilohertz. In contrast to that, you see here the mioty, and mioty really splits the data in many, many chunks, as you can see here. And these chunks are very, very, very small, are of a narrow bandwidth. So therefore, so the chance that a significant number of these chunks is actually hit by somebody else using also that frequency band is very limited. I mean, it's pretty clear, so you will lose some of these tiny frequency hops, but the system is prepared for that. And because you spread it over such a long distance, over such a long area, so then you reduce the probability that a significant number of these tiny chunks really gets hit. And that's one key why mioty really gets a very, very good robustness in terms of these interference channels. So there you can really get a very, very long range connectivity due to that approach. Another thing that is also relevant is the case where you have many, many devices accessing the channel at the very same time. Because in case of LoRa, so if you have two signals using the very same spreading factor, if they hit each other, the frequency domain, so then they are lost. So then you have a collision and you can't recover the data. But this is different in case of mioty because there's a software-defined radio receiver behind that. That means that you can have many, many packets that are transmitted. And then eventually it can look like this. So you have here like 2000 mioty packets per minute that are transmitted. And you can see all these tiny chunks here. And of course, there will be some collisions. But if I zoom in to that frequency band, you see, yeah, there's still a lot of space left between these tiny chunks. There will be some collisions between some transmitters, but I mean, the system is prepared to recover those. But nevertheless, there's still a lot of space. And this means that we get a very good robustness, a very, very good throughput of the system, even in densely occupied areas. Okay, here you can see now the channel capacity that you can achieve. So what you see here on the x-axis, so these are the packets per minute that you can achieve using mioty as a function of the packet error rate. And you see, for instance, for the classical modes, so if you have 5,000 packets per minute on one channel, you still have a packet error rate of 1%. If you compare that to LoRa, so you see that the performance is much, much smaller. And so for LoRa SF12 on a single channel, you end up at a packet error rate of 10% with 2 or 3 packets per minute that you can transmit, while mioty really allows you to transmit many, many more packets on the very same channel. And that's, of course, very interesting if you have some areas that are densely populated, because it's not only your packet that counts, because also your neighbor may transmit some kind of data and you can't really control them. And so therefore, eventually, you are in an interference-limited scenario and you have a lot of packet collisions using LoRa. But this is not the case for mioty. And this means you have a much better scaling if you really have scenarios with many, many users. And that's the main benefit of mioty compared to LoRa. So if you have scenarios where you start to see a significant degradation of the packet reception rate. So then this is mainly caused by interference because you're running into the capacity limited area. And in this case, especially, mioty will significantly improve the throughput of your system. Okay. One additional thing that is also relevant, and that's already my last slide that I want to show to you, that's the power consumption of the system. Because eventually, the power consumption depends on the actual on-air time, so the time where the transmitter is switched on. If you now compare the different systems, you can see that for a given length of payload data, the on-air time of mioty, you see it here, so that's this yellow curve, is smaller than the on-air time of LoRa SF12 and LoRa SF11, which means that the system requires less energy to transmit data with a very at a comparable robustness. Of course, if you then take a look at higher data rates, so LoRa SF7, for instance, requires much shorter on-air time, therefore it's much more power efficient, but of course at a lower level of robustness. And in general, so in order to get the very same robustness, you have to compare these ones, and here you can see that mioty really outperforms LoRa concerning the power consumption. And that's also what you can see here on the next table. So I'm not able to show the table somehow. Here we are. So this would be the battery lifetime of different modes using a 1000 milliamp battery using the SX1276. So that's the Semtech LoRa transmitter. And using mioty, you can achieve something like 9 years of battery lifetime. With LoRa SF7, you can achieve 57 years. So a very, very long time. But on the other hand, of course, with a lower robustness. And if you then compare mioty with LoRa SF11 and SF12 that have comparable robustness to mioty, you can see that the on-air time or the on-air time is much lower for mioty. Therefore, the battery lifetime of mioty is much better compared to the existing system. Okay, so these were the benefits of mioty compared to LoRa. And then I would like to pass to my colleague for the next slides.
Okay, thank you very much. So hello everyone, as Dario introduced me, my name is Szabó. I'm the lead embedded developer at LORIOT, and I would like to show you some slides about how LORIOT supports mioty and how we can help you to get started in the mioty journey. So first of all, how do we support mioty exactly? Here, can you see the whole slide? I think you can, right?
Yes, we can.
Okay, perfect. There's always questioning the animations. Anyway, so how does LORIOT support mioty? As you may know us already, LORIOT is a hybrid network service center supporter. So mainly operate on the backend side, but we got some other embedded products that can help you with the gateway side of things as well. The good thing about the backend services is that we both support LoRaWAN and mioty. That's why they are hybrid. So if you happen to use already LoRaWAN and you're looking at other options, looking into mioty and looking to see how it can improve your network, or you need one of those robustness or other features that Jörg just presented, you might want to consider switching to mioty. And in that case, if you're already using LoRaWAN with our backend, for example, we can help you with that quite easily due to a hybrid nature of our backend services. That of course means that it's a really easy integration with the existing application level. So if you already have a service running and you want to switch over to mioty, you can keep your application level and use the exact same API calls to access your data. You can utilize well-established UI and behavior, because if you've been using the service with LoRaWAN, you can keep using almost the same interface, of course, with the adequate differences between LoRaWAN and mioty, but the same familiar experience. And the good thing is that free accounts are available. So if we go to this next slide, you can see how you can scale your operation in mioty. I think if you're getting started in the world of mioty, the left column is the most important to you. And at the bottom, it says free. So that's right. If you want to get started using mioty and you need a backend services to get started, LORIOT can get you there for free, pretty much up to 30 devices. You can try the services. And if you just have a POC product, or you want to try how this whole mioty ecosystem work and want to get a hands-on experience, you can do it with our free backend services. And of course, if you happen to like it, I'm sure you will, you can keep scaling up to higher and higher levels with more professional and private server options. On this next slide, we have one more added point, because you might have the question, what about the base stations? Because LORIOT mainly provides the LNS, I mean the backend services. In case of LORIOT, in case of LoRaWAN, that's the LNS, and in case of mioty, that's the service center. We provide both. But what about the other parts of this network? What about the gateways, or what about the base stations in case of mioty? And in case of mioty, for the base stations, we got you covered also with miotyGo. And the next slides are going to be about that product. A bit of a motivation, like why do we need miotyGo in the first place? Whatever this product is, why do we need it? And the reason is that mioty, always a really great technology, a person thinks so, and you could see many, many scientific reasons why in certain situations it can perform significantly better than LoRaWAN. Mioty is still in its early adoption phase, and end users, most of them at least, I'm sure many of you watching this right now have heard about it, have seen it, but still maybe a bit inexperienced, lacking real-world experience with the technology, seeing it actually work on their network. And of course, interest is there. That's why we're also in this call, because people are interested in technology. They want to know what they can do with this technology. But when it comes to actually paying good money for hardware, paying people, employees to set up these networks, understandably, these industry players are still a bit hesitant to do that. And us at LORIOT can already provide you the free service in your account I just mentioned, but the next step is getting the base stations running, which are physical devices, and that could be a big upfront investment. So it's still noticeable, and you still might, some tests, some POCs might stop right at the point, because these base stations, especially if you have to buy multiple of them, get quite costly. And that's the motivation. And then we get to miotyGo. What is it exactly? How are we going to solve this problem? Well, miotyGo is an educational software base station solution. So pretty much what it is a piece of software that you can run on your own easily accessible hardware. We're going to talk about that a bit more in details, what do you need exactly. But you can run this piece of software. I'm happy to say it's also completely free of charge. And then you can pretty much set up your own software base station. So for very little money, you can get started without having to invest in multiple commercial industrial grade base stations. And the second point is, of course, that it's based on cheaply and readily available hardware. The software is developed by us, but it's really important to mention that it's backed by the mioty Alliance, so the official alliance behind mioty technology. And it's also helped by Fraunhofer Institute, pretty much the creator scientific institute behind mioty as a technology. And one very important distinction is that miotyGo is not aiming to be a replacement for commercial base stations. It's not meant to replace your commercial grade, industrial grade hardware solutions. It's meant to be an introductory, non-commercial educational tool. And for that reason, we have a hard limit of 10 simultaneous attached endpoints in the software. But that's not really going to be a problem if you're just trying to get started in the world of mioty and try to experience how this would look like, or try to assess maybe, can it actually go that far? Can it actually deal with this much interference? You can all do this with just 10 devices. Okay, a quick feature list. What do we offer exactly in this package, in this free package? First and foremost, the most important one is BSSCI 1.0 support. If you don't know what BSSCI is, pretty much it's the standardized communication protocol between backend services and mioty base stations. So while with LoRaWAN, you don't really have this protocol, no one really defined it well. Sort of the basic station has become the de facto standard, but it's not really official. In case of mioty, this is better handled from the get-go. It was said that we use BSSCI with different levels of protocol, different versions of this protocol, and everyone who wishes to use mioty, both on backend side and both on base station side, should implement this protocol. So that's very good news, because pretty much you can use the same software with multiple backends. You're not really tied to any of them, as long as they support the official protocol, of course. The second one is that we support mioty uplinks. That's, of course, a big one. We have to support uplinks, or most LPWAN systems would just don't have a point existing. We're saying that we support uplinks because we do not support downlinks. That's not a software limitation, that's a hardware limitation. You will see a bit more what exact hardware requirements do we have. But in order to keep the cost low, keep the hardware cost low, we let go of sending downlinks. So it's going to be uplink only. solution. Again, I highly doubt this is going to be a problem. Mostly real-world applications, LP event systems are uplink, heavily uplink oriented anyways, but it's just something for you to know. Detailed log messages just help you to assess if you have any problems, if you have any questions, what is happening exactly inside this box, what is going wrong, if something's going wrong, what can I do, what did actually was detected by the antenna, by the device. Then you can get these questions answered by detailed log messages. Another important point is it's easy to use and it has a self-extracting installer. Again, it's not meant to replace commercial solutions, but because having a bit less features, our main purpose is to make it easy to install, easy to deploy. So if anyone's interested, it's not hours and hours of compiling stuff and finding the right platform and so on. Just buy the pieces of hardware that you have defined, and then you can run a really simple self-extracting installer available on the web. And it can get going in pretty much minutes, I would say. Another important feature is support for multiple regions. That's important, so it doesn't really matter where you are in the world, you can find your region and use it. And in the future, we're also planning on introducing another feature, which will be a web interface. So to make sure it's even more easily accessible and without any problems. And then about the aforementioned requirements, of course, miotyGo is a software solution, but you cannot receive uplinks, any messages or anything in the air without actually having your antenna, having some radio front end, having some processing power, and so on and so forth. What we choose as our base is a Raspberry Pi 4. The reason is very simple. Raspberry Pis are, at this point, it's everywhere. I highly doubt you could get into a tech company's office these days and not find Raspberry Pi hidden somewhere in the corner doing something, some services. Or I'm sure most of you being in school, if you have some technical interests, have at one point held, used, or owned a Raspberry Pi. What we need is Raspberry Pi 4. You can buy it for around 70 euros. And for the extra radio part, what we need is an RSP1A SDR. That's a very widely available SDR radio front end. It's used by many people for hobbyist purposes and for other purposes as well. Again, if you can get it for 100 euros, it's very popular. It's easy to get. You should be able to get your hands on it. And the software is free. So if you add all these up, you get 0 euros for the software, 70 for Raspberry Pi, and around 100 for an RSP1A. So for around 150, 170 euros, maybe get some discounts as well, you can get a base station up and running, which I think is really good compared to how much actual industrial grade equipment can cost. So if you need a couple base stations, you can really, for a couple hundred euros, get your whole network going, get the backend services for free, and yeah, installation setup time is minimal. So that's it. For the backend services, it's free. For the gateway, or in case of mioty, of course, for the base station side, you can get miotyGo. There's only one question remaining: how do you get your devices from? But I'm happy to say that probably Jörg is having something to say to you about this. So Jörg, whenever you're ready, please take control back. It's your turn.
Okay, so thanks, Daniel. And I will take over again. So I think I just switched off the presentation so that you.
No, we can. Oh, no.
Okay, so I think you have me now full screen, right? And so what I want to show you is now the hardware setup. So here you can see the Raspberry Pi 4, where I installed the miotyGo software. And this is now this SDR Play software-defined radio that has already been mentioned. So it's just connected via USB cable, and the Raspberry Pi 4 is then connected wirelessly. And that's the only hardware that I basically require for setting up the miotyGo station. I now will share my screen, and so then you can see more details. So I took the chance yesterday to install the software, and so this is now the miotyGo software. And I now registered here my miotyGo network. And so this is the base station that I have just shown to you, which is based on this Raspberry Pi 4, which is also running right now. And let me just go back. So now I can also show you the applications. So I have some mioty test application here. And you can see that I have registered an endpoint. We'll just show it to you in a second, how you can create those endpoints. And here you can basically see the data that I have been transmitting since some time, including the payload data. Of course, here it's just in a hexadecimal representation. So if you translate that, so that says hello. But of course, you then can connect some other software to really push the information into that software. So what I would like to show you now, after setting up this or after showing the miotyGo, is how to set up these mioty devices. And what we have there is available on GitHub. So it's available on github.com/miotyIoT. And so there we have open source software for Arduino and for the Raspberry Pi Pico. And if you then go to that website, so you will find a really comprehensive manual which really describes how you can set up these devices, how you can build these devices, and how to use them in the end. So that's available for the Raspberry Pi Pico and for the Arduino. So this is now the Raspberry Pi one. So I just opened that manual. So you can also download that. And I mean, eventually it's very simple. And so this is the complete hardware configuration that you need for setting up a mioty transmitter. So it's just some classical RFM 69 or 95 module. So that's what people already know from LoRa. So that it's also based on this RFM 95 module. Then you have to connect that to the Raspberry Pi Pico, and that's it. So then you just have to connect it to the antenna. So there are also some nice devices available that look like this one. But you can also solder it yourself based on the documentation that you have available there. And what you can then also do, I will now show the Arduino interface. So this is then the code. You can just install the libraries and then you can play around with this. What you just have to do is add in here the EUI64, so that's the address of your device, and the network key. And then you register the network key and the MAC EUI inside the miotyGo or on that website. And then you're already done. So then you just have to program that. And you then can just use that example to send some kind of messages. And here I just added the text hello. And using the software, then you can basically just send the text hello, and that's it. And then there are just some flashing LEDs, a break of 5 seconds, and then it starts over again. But you see that eventually it's getting very, very simple to really realize some kind of FSK transmitter chips, which are really very common in the sub-gigahertz frequency range. And the additional stuff, the complete mioty encoding, is purely software-based. Okay, that's it from my side. So if you have any detailed questions concerning that, you can also contact me. But right now, I will just hand back to the others.
Thank you. Thank you very much. I will ask also Daniel to get back to the video if there are any
Right.
questions. Yeah, you have got the link as well that I posted in the chat as well. So well, first of all, we had a question. You can ask any question in the chat or in the QA session. You should see the button on the top menu of your window. First thing, we've talked about. I wasn't sure about this webinar if it was too technical. No, I'm now looking at the attendee list, and it seems that we have a lot of experts, to be honest. So I'm not worried anymore. But I would ask Jörg if we could explain quickly what is this telegram splitting and the forward error correction that makes mioty, say, so special and perform so well according to the graphic that is shown before.
think you're muted, Jörg. Please start.
Oh, sorry, I'm still muted, but I already took over control. So the main benefit of mioty really is this splitting of the data. So you see here the different packets. So that's again the LoRa packet, LoRa SF12, and this is mioty. And this is the zoomed version of that. You can see that the data is really split into these multiple chunks. And these chunks are protected in such a way that you can lose part of these packets. So you have an overall packet that contains 24 of these chunks, and you can easily lose like 12, 13 of these chunks. And the forward error correction that is used on top will then be able to recover the data so that you can receive the data without errors. I mean, you can already see it here. There's another transmission, so that's not mioty, that's something else. And there's a high probability that the data already is affected here of that hop. But we don't really care because there are 23 hops left over. And therefore, if one hop is destroyed or affected by an interference, you can still recover the data. And that's really the high level of robustness that is offered by mioty compared to other systems. And that makes it really robust.
Thank you. And we also said that mioty is particularly suited when there are a lot of potential collisions. So when the bandwidth is very crowded. It's already the case in IoT or not yet? What's your...
I mean, that's a good question. I mean, that depends on the location where you are. Let me just go back to the spectrum that you see here on that slide. So that was the spectrum measured in Adenta. And there you can see that the spectrum is really, really crowded already. And I mean, that depends then on the location where you are. So when you are somewhere in a rural area or in an area where these IoT devices are not yet that popular, so then you don't have that interference. And then all systems will work more or less with the same performance. But the really decisive part between the different systems is then how do they actually work in a scenario where you have a lot of IoT devices accessing the spectrum. And it's clearly foreseeable that in the future there will be more and more devices using that license exempt spectrum so that the amount of collisions will go up. And then, of course, these things will get more and more important. Otherwise, the throughput of your network will go down, and the packet error rates, so the lost number of messages will really increase a lot. So therefore, even though it works right now, so this may change in the future. And I mean, so just think you are an operator of some network, and then there's somebody else also setting up a network in the very same town, and this will cause interference to your network. So even though you have properly planned your network, if somebody else also adds some nodes, so this may also mean that your network will collapse, and you can't control that because it's in license exempt band. And if you use mioty, so then you can be sure that you can accept a very, very high throughput, even though you have a lot of other devices accessing the channel. And that's the main difference between the different systems.
And I wanted to actually, but I see Daniel already raising his hand, and I wanted to add to what you wanted to say another question. So this is where the hybrid approach comes at end, you know?
Yes, so of course, if you can mix mioty and LoRaWAN, it really comes handy because you can just, if in those areas where you need this extra protection against collisions, you can use mioty, and in the areas you don't, you can keep using LoRaWAN without any interruption to your existing services. And I want to add actually, because first I think you asked if it's already the case with some networks. It's not, doesn't happen too often, but of course, without naming them, we already had a few customers having problems with collisions in LoRaWAN systems. And they kept asking us like, hey, we're losing these packages, we're having these problems. What can we do? Can we buy more gateways? Shall we put down higher towers? What should we do? And realistically, there wasn't a good solution because buying more gateways, buying more antennas didn't really help their use case. It was the collisions in the air. So we couldn't, now the system is still working, so everyone's happy, but they're really on the verge of not having a functional network because of collisions. And of course, buying more gateways is just not going to help them. So It was one of the cases where just pouring more money on the problem and buying more hardware is not going to solve the case. So in that case, they should really consider it. This unknown client of ours consider using mioty instead. So it's already happening with some people.
Yeah, Daniel, you're raising a very, very important point. So if you have already an interference limited network and you increase the antenna height, so then you will further degrade the performance.
Exactly. So
it's counterintuitive. Yeah, but this is why not the experts are useful. When another case that comes to my mind is, and we talked about it a couple of months ago in the first webinar of the series. It's in smart cities. We had this webinar with deal metering. We were talking about, of course, the high number of meters of sensors that are needed in such a use case. And we also mentioned mioty in that occasion because, of course, in a city where as you mentioned before, you can have more than one network. I mean, different operators can coexist, and especially when the frequency are say unlicensed. And so in this case, mioty also was an option, a very good option, because it guaranteed a little bit more robustness. And let's say future-proof, because as the time go with more and more sensors, with more and more sensors sending data, the spectrum is going to look like your picture very soon.
That's a real one already.
Another characteristic of mioty is mobility. That is apparently works very well in mobility use case. Do you have like an example of some data in this regard?
So I haven't prepared anything for this webinar today, but I did an extensive study on the mobility performance of mioty and LoRa, and it turns out also that mioty is really receivable up to speeds of like 160 kilometers per hour, which is pretty high. So for LoRa, it really depends on the spreading factor. The smaller the spreading factor, the better the performance normally. But so the classical mode, so if you really want to achieve a comparable performance, so like LoRa SF11, for instance, so then you end up at 50 kilometers per hour. So that's the maximum speed that you are able to support with LoRa SF11. So if you go down for the other modes, so then it really depends on the detailed configuration. But in general, so mioty really outperforms LoRa by really a very, very big factor when it comes to mobility.
Thank you. I don't know if there are any questions for our audience. As a reminder, you can use the chat. I'm also sharing the link of the mioty Alliance, where you can find more information about this technology. And as we are talking about the mioty Alliance, that, as said, is co-host of this webinar and co-sponsor of IoT Sparks big event that are in September. I would like to invite to the stage, to the virtual stage in this case, Peter Hedberg, that is General Manager of mioty, should be in the audience as well. Please show up if you're there.
Yes, I'm here.
Welcome.
Thank you.
Welcome and thank you, because I just wrote it to Peter a few hours ago and say, oh, if you happen to be in the webinar, I'd like you to join, because I'd like to ask you a couple of questions. And why one of these questions is, well, what is the mioty Alliance? If you want to say introduce it, please switch on your camera. You should be allowed.
Can't you see me?
No.
I've turned on the camera.
I only see the initials.
That's weird. My camera is turned on, so. But you can hear me.
I can hear you. I don't know if I'm the only one not able to see you. If it's not the case, please, everybody can make me a sign. Well, so first of all, yeah, let's don't stop the show. What is the mioty Alliance, and how it is helping the ecosystem to thrive and the increase the adoption of mioty in the market.
So well, as you've all seen, we have a pretty good technology as our foundation here, and this technology, the whole purpose of the mioty Alliance is, of course, to promote this technology and make sure that it reaches as many as possible. And this can only be done via the members. The core of it all is to, of course, create a community which fosters collaboration between the partners, making sure that they can provide the right solutions to the end customers, because IoT very often is quite complex. You will need several players to actually deliver a complete solution. But then, of course, also we as an alliance, we do a lot of promotional activities. So online, we do articles, we do events, interviews and things. So we always try to involve the members, making sure that their voice is heard. So traveling the world, so far mostly Europe, but still a lot of events. We do them together with our members. And of course, we also try to push the continued development of the technology. I will put some cliffhangers here in the air, but there will be some interesting new evolvements coming over the coming 6 to 12 months as regards the mioty technology as such, that will allow some really cool things just by using the technology in different ways. So it's a community. We're around 55 members today, growing pretty fast. 10 new members only this year. Lots of interest, which is great for us, of course, and we'd be happy to have a discussion with anyone on this call that's interested in the technology and feels like, okay, this ecosystem could be interesting to be part of.
Yeah, absolutely. And you mentioned the technology is one component, and the collaboration is the other one. And of course, the collaboration is also a little bit at the basis, the foundation of the event we are working to deliver in September, which mioty Alliance is one of the sponsors. So also thank you for that. I would like to ask what role collaboration play in successfully meeting the challenges that the Alliance poses?
Well, it's crucial. It's at the very core of it, because, as I said here, these if you look at one case like a metering or so you build up a network with some meters and stuff, and then that would open up the possibility for someone else doing other use cases in the same network. So if you have the connections in between the members in the alliance, of course, you can ride on one installation being made, and then you can add on sensors and other solutions onto that, because it's a completely open and interoperable system. It wasn't mentioned here, but it's actually a standard. So there's no lock-in from vendors or anything like that. So anyone can use it, and that also creates hopefully a more vibrant ecosystem, allowing any hardware vendor to join in and develop the products and sell products into this ecosystem.
Thank you. Well, I couldn't be more agree with you, especially as LORIOT is one of the first believer in this new technology since already 2020, and I think that now the technology is really mature and the ecosystem is much more mature and ready to deliver an solution to the market. So really, and we are seeing already some. So thank you very much for joining us. One more, let's say, call for question if you have from the audience. I've already seen one which was answered already about the slides and this presentation, this webinar. Of course, the webinar would be is being recorded, and the replay will be posted probably already tomorrow on our YouTube channel, and also shared with the mioty Alliance. So probably also will be available also on their channel. I invite you to reach out to Jörg, Daniel, and Peter if you have question about mioty, miotyGo, and mioty Alliance. And what else? As usual, let me invite you to our next webinar. It will be about environmental monitoring, and together with DataCake and Descent Lab, and from our side, our newly created division, LORIOT Versum. So this is another appointment if you would like to explore the climate resilience as a service, and the impact that IoT can have in our future. And of course, I invite you to connect and check our event happening in September, Valencia. It's an in-person conference, but also online, and you can find more information in the website. I don't know if I'm forgetting anything. Let me go back one moment here to the slide, just to highlight that you have here his email as well. I can share also that in the chat, doing it all live. And yeah, that's it. Thank you very much for joining us again. It's nearly 1 hour, so we've been very precise with the timing. And thank you very much. See you next time. Next appointment 27th of May, so end of May, and then I'd like to meet you all and shake your hands in September. By the way, Peter, if you're still there, I have another question. Where everybody can meet the Alliance at events these months before September? Of course, September, you and not only you from the mioty Alliance will be present at IoT Spark.
So we will be at the IoT Visions 14th of June in Zurich, for instance. I'm actually going next week to IFAT in Munich to join one of our members, Deal Metering, in their booth to talk about mioty there. And then there are a number of other. I don't have them in my top of my mind here at the moment. The 2 months the closest.
Your agenda must be worse than the crowded spectrum that you have started before. So yeah, we have done 2 appointments already, but follow the mioty Alliance on LinkedIn to be, let's say, to know where you can meet them, and yeah, let's start the conversation. Thank you very much to everyone, to our guests, and to our audience. See you next time.
Thank you, everyone. Bye bye.